Just to confirm, am I audible?
Yes, sir.
So, basically, this is the first class for our power system protection and switchgear. Uh, and we know this final year classes are going to be online. This protection subject, if you understand that why do you require this protection and what is the meaning of power system protection and a switch gear. So here in this particular case, we'll be talking about two things. One is called power system protection, and the second one is nothing but switch gear. So, if you understand the power system protection, so power system means it is divided into many stages, like generating station, then we are having transmission system, then we are having distribution system. So the protection of power system is very much important to supply the power from the generating station to the load side. However, the second one we are having, that is called that is nothing but the okay. I'm just trying to convert this one to this एक ऑनलाइन क्लास ले रहा था फाइनली मैं आता हूँ आपके पास So basically, this subject power system protection is divided into different units. In the first unit, we'll be talking about the electromagnetic relay. However, nowadays, wherever we go, we'll see that electromagnetic relays are now obsolete. We'll be finding the digital relay. And in the second unit, if you observe, we're having the fundamental principles of distance relay and application of a transversal and protection. Then relay coordination. Why do you require this relay coordination? We'll talk about in today's class. So basically, if you understand this fundamental protection of a differential protection, then transformer protection, this all we need to understand the what is the need of the protection scheme. Then after that, if you understand if you go for the next unit, so we'll be having the CTPT, that is called current and voltage transformers in our system. So this current and voltage transformers, basically it will be available in the substation as well as distribution system. The purpose of this current and voltage transformer to reduce the voltage and current to certain extent so that they will be measurable. However, previously we have understand the use of the CTPT in the third semester. A particular this protection subject will see that how the current and voltage transformer will be utilized for the protection system. Then Unit 5 will be covering the numerical reading and how do you convert the analog signals to a digital phaser, or how it will convert the analog signal to a digital data, that will be covered in that Unit 5. And Unit 6 is nothing but Different types of overcurrent relay, distance relay, differential protection scheme will be, you will be observing. This nothing but we have to understand how the digital protection will be carried out. So the first one will be the book will be utilizing. So this book already I have shared in this MS team. You may go and see this book, and otherwise my slides and other things, it will be okay to read this subject. So particularly in this side, if you observe the power system structure, the generation we are having, it will be nothing but at low voltage level, that is 11 to 11 kV to 24 kV. Then we have to step up the voltage by using a step up transformer. So basically the transmission system voltage level we are having in India is nothing but 138 kV to 765 kV. Then after transmitting the voltage nearly up to 200 or 400 kilometer, we need to step down the transformer, step down the voltage up to sub-transmission level. So basically the voltage level be here will be nothing but 33 kV or in between 132 kV or 138 kV. Then further in our cities, it has to be decreased by a distribution transformer. So this distribution transformer is nothing but basically decrease the voltage up to 0.4 kV up to 11 kV. Then the whole household purposes we are having 100 220 volt to 440 volt. So this is nothing but the structure of a power system. And when we are talking about this power system and the switchgear and the protection of the whole system, why do we require this protection? Because if you observe these transmission lines, the transformers, and all these lines are there, they're open to the nature, they open to the environment. So you may see at any time any problem may happen. They are open to the bad weather, they are open to the different type of storms, they are open to the different type of heat waves. So what happened, because whenever we are having this transmission line, if you observe this transmission line, the wire is not touching this tower. Otherwise, if somebody will go near to the tower and it will touch the tower, definitely it will be getting a shock. So for that reason, what will happen, the wire it will go like this and it will be overhanging through the insulators, and the insulators will be nothing but having that ability to withstand that voltage. So sometimes, so whenever the insulation is broken down, so what will happen? The sparking will be there. So if the sparking occurs further, the insulator will be burned, and this tower is nothing but grounded. So what will happen at this point? The current will be flowing through the tower. So when the current flows through the tower, we see that there is a when current flows through the tower, then automatic the fault is being created. So, and when the fault is being created, we know that all this path is nothing but bypassed. So we are having a system where the current is very high. When the current is very high, you come after some time. I'm taking a class. So when the current is really high, then what we need to do? And the current is how much high? If you want to understand in the transmission system, the current will be nearly 7 times higher. So you're talking about normal current that is 1000 ampere. The current increases up to 7000 ampere. Then it will burn all the insulators, transformers, generators, which is available here. So during that point, what we need to do? We need to operate the breakers we are having here in the transmission system or the substation, so that the transmission lines will be protected. So after that, what we need to do, we'll go to the point where the fault has been created, the insulators have been burned. Then after repairing that, we need to restore the power. Okay, so for that reason, what we have to do, where we have to place this relay and a circuit breaker, we need a substation. So that substation is nothing but a point where we'll collect the power from the generating station, and from there we need to transmit the power. So the transmission of the power through the transmission line. So the transmission line is open to the weather. So at many time the fault may be created. The fault may be created means what? It may be because of our external regions, or it may be because of our because of our any other insulation burning. However, the earlier distribution transmission system we are having, basically the power system is nothing but it is a central unit, and from there the power is being transferred. Slowly, when the power requirement is growing, so what we have done, we have added some new generations in our system. Basically, they are called as distributed generations. So now, the what happened? The power is not only flowing from one generating station; they are also flowing from multiple stations, like solar is there, wind is there. So we can collect the power from any point and we can push it to the grid, and the grid will be utilizing the power. So as I discussed in this particular case, that whenever there is a fault, how the fault will come? Because of the insulation breakdown. If the insulation is not there, if insulation is burning, then what we need to do? We need to immediately take a decision to trip the circuit. And what is the time period? The time period is nothing but is very less, because in case of our transmission system, the time period we are talking about, it is a 5 cycle. However, in case of our distribution system, we are talking about the protection of the line. So the distribution system protection, basically it is done by breakers or MCCB or any other type of relay. So in the distribution system, whenever the fault occurs, definitely the current will be really high and the voltage will be down. Because if it is grounded, then all the current, because if the insulation has broken, every equipment is grounded because of the safety. Because we want our personnel who is working near to that one is should operate in a safe manner. So when the equipment is need to be very safe, and we are protecting a ground over here, then when the fault occurs because of the insulation broken down, so what will happen? The current will be really high. So during that point, we need to break the circuit. Whatever the faulty element is there, we need to break the circuit. So in those cases, what we need to do, we'll be having the two things. So one is called relay and second one is called breaker. And the time period for which the current is flowing, it should be very less. Otherwise, if you allow the longer time period, what will happen? Definitely it will burn everything. So for the protection in the distribution system, we see that we use a principle that is called, when the current increases above the certain value, then that is called overcurrent protection, and that is basically utilized for the distribution system, 33 kV, 66 kV. However, in the distribution system we are having, the transmission system we are having, the overcurrent protection is not utilized. You will see that why the overcurrent protection is not utilized. And this transmission system, basically it uses both voltage and current. However, in the distribution system will be using only current. So the transmission system, when we use both voltage and current, it detects the impedance of the transmission line up to which the fault has occurred, and it takes a decision that there is a fault and it needs to break the circuit. Similarly, the other equipments we are having, that is called inductor, then transformer, then reactors. So all these things need to be protected by this differential protection. So in this slide, we may see that where our differential or all protection schemes will be utilized. So basically, in distribution system, our protection system will be either overcurrent protection or differential protection. And in case of transmission line, because we have to protect the system by using our distance protection, or so many other protection schemes are utilized here, that is called PLCC, power line carrier communication, and carrier rated protection schemes. We'll see all these protection schemes here. And in case of generation and transmission, we'll be going for unit protection scheme. These are nothing but called unit protection schemes. These are called power system that were differential protection schemes. So When we are having this power apparatus, basically we require two things. One is called control equipment. So control equipment is based on all the control system we have studied, and the protection equipment, basically we are going to understand that how the protection of equipment should be done. But when you are talking about the power system, the voltage and current is really high. 400 kV transmission line, then current will be really high, 700 ampere. So how to measure the current and voltage? We need to put a CTPT so that the voltage and current will be really down to 100. Voltage will be down to 110 volt, and the current will be in the secondary side 1 ampere or 2 ampere. So in those cases, what we need to see, the current and voltage has to be measured, and this will be given to a relay. That the relay, it detects the fault means if any insulation one will be there, then continuously the current will be high, and that high current will be detected. And when it will detect the high current, then what it will do, it will give a signal to the circuit breaker, and the circuit breaker will operate. The circuit breaker operates means immediately the faulty element will be disconnected. So in those cases, what we require, how do you go for this type of process? So basically, we need to identify the different type of equipments will be having relay, will be having CTPT as a sensor, will be having circuit breaker to open the circuit. But the challenge is that how to identify that there is a fault, because in our power system we'll be going through different type of changes, like load changes. Fault will be there that because of the neck, some and, transient faults will be also there. Equipment and operational failures will be also there. So what we need to do, if you will not identify the fault in our system, that is going to definitely damage hugely. It is nothing but only economic damage. It will also disturb the total supply of the power. So it will be huge, a costly things will be there. The second thing, if you observe that if some transformer is burning like this in this slide, and because of the fault, and why it is burning, because we are unable to identify the fault, and when the fault is there and the relay protection system has maloperated. So when high current flows, the transformer is burning, and if anybody working nearby that one, definitely it will blast, means that person may lose his life. So because of that, the protection system needed to be considered very means we need to protect the system intelligently, so that we should not have any type of fault in our system. So as you see that whenever there is a fault in our system, the loss is very huge. Means suppose your transformer, we are having 500 MVA transformer is burning because of the fault. Now you want to replace that. So 400 after this has burned, you have to replace the transformer, because without that we cannot transfer 500 megawatt. So when the 500 megawatt has to be transferred, this transformer is not a machine which is available in the market. You will go there and you will purchase it, right? So when it needed to be purchased again, so how do you go for purchase? And that too, one transformer may be 30 crore, 100 crore. So it is not like that you will be sending the quotation to the BHL, and BHL will be giving you this transformer. So there are a lot of effect, lot of processes are there. It may take 1 year, it may take 2 years. Okay, so for that reason, what we need to do, we need to protect this type of transformer. We need to protect this type of transversal line where this type of cases may happen. Okay, right. But we have to design our system in such a way that any type of fault should be there in our system, it should be detected. Okay, any type of fault should be there it should be detected. So for that reason, when you understand that the fault is a very rarest case, means insulation burning and any other burning will be there, so that the current will be really high, and we will see the fault current will be really high. So, and that will burn the all the circuit equipments like transformer, inductor, and other things, right? So then when we are having we are designing this relay is nothing but to sense the fault. Means there are different operating conditions, there are abnormal operating conditions, there may be transient conditions, there are fault conditions. So apart from that, we have to select only fault, right? So this fault needed to be detected, right? So when you are trying to detect the fault, the problem is that there are so many incidents are there. We are not having any fault, but it's transient. Like your tree is coming to the transverse line, and due to wind, it will come to the transverse line. It will touch, and after some time, it will go back, right? So when it will go back, then what you understand that it is a transient. The fault is been created whenever it is touching, and then going back, it is cleared automatically. So similarly, several transients will be there. Now your relay has to be prepared in such a way it will operate for all the type of fault. But if any transient or other things are there, then it should not be detected, right? So load change are there. Transformer, whenever you restart the transformer, it will draw a high current for few cycles, and you are putting a induction machine that will also create draw a high current. So that may be also detected as a fault. So the relay we have to design the design should be in such a way that it should detect all the type of fault, and it should not operate for a transient event, right? So, however, whenever we are talking about this relay, basically low voltage level means 11 kb, 33 kb. We use fuses, right? But high voltage system, what we are talking about, it is nothing but we are having relay plus circuit breaker. So the relay we are having, it is just to sense that there is a abnormal condition. If it is fault, then it will give a signal to the circuit breaker. The circuit breaker will trip. Similarly, when we're talking about this high voltage system, we need to say that if the system is not very fast, which why we are talking about this circuit breaker. Circuit breaker means it is a switch; it has to open. But whenever we are trying to open a high current like 1000 ampere, 2000 ampere, if you're trying to break a circuit where the current is really high, in your lab you may have several experience that whenever the circuit is there you are trying to open, you'll be having sparking. Why the sparking occurs? Because when you are trying to break the circuit, the inductance is present in our circuit across that whatever the voltage developed, that voltage potential comes across the switch. So when the contact opens across that, if the voltage is high, then it will cause the ionization of the air. So the sparking comes. If the spark comes and the energy is really high, then what will happen? You will see that it's burning. So that is really bad. Means definitely you are trying to break the circuit because there is a fault, and if the circuit breaker does not break, or if the circuit breaker is breaking, and during that point the sparking comes, it will allow the fault current for few seconds. So it will further damage all the circuit equipment, right? And the second thing you are talking about, that is called system stability. All of you know that you are having the critical clearing angle. You have already studied the equal area criteria. So when you are having that power system is operating, and if you want disconnect the circuit within fraction of second, then you see a fraction of second you are not disconnecting the fault, then what will happen? The generator will oscillate and the delta will continuously increase. So when the delta increases, you see that there is a after some time it will be going unstable. So we need to identify that circuit has to be opened by the circuit breaker within a small time delay. So that time delay has to be decided before. So by which we are doing that analysis, like called equal area criteria and other things. So considering all these things, so how much time we're having to dictate the fault? It is in milliseconds. And you are talking about basically the relay. The relay is going to operate within 2 cycles. The circuit breaker gives normally 3 cycles to open. Are you able to do it by human intervention? Like you are there in the substation and somebody will ask you, hey, fault has come, and you go and trip the circuit. Can you do that? No, no, not possible. Why? Because when you're talking about this fault and how much time we are having to operate the switch, if the fault current flows for a few seconds, definitely because of the heat generated by I square R into T, what will happen? The temperature will so rise, and you will see that all the equipment have been burnt. So for that region, what we need to do, it has to be automatic. So how the automatic things is happening, we need to understand. So what we need to do, we have to use a sensor. So basically the sensors are nothing but a CT and a PT. So the sensors will reduce the voltage current to certain level. The current is reduced to 1000 ampere to 1 ampere, and the voltage has reduced 400 kV to 110 volt, and this gives the signal to the relay. So this relay basically detects either there is a fault or not. If there is a fault, then what it will do, the relay contact will be closed, and due to this one, the close of the circuit, what will happen, the current will be flowing through this circuit. When the current flows through the circuit, this is the trip coil. So circuit breaker coil is energized, and it will be open, right? The circuit breaker contacts will be open. In circuit breaker, we'll be having two contact. One will be fixed contact, and second one will be movable contact. And when the trip coil will be energized, we'll observe the this circuit coil. It will be energized, right? So now, if you observe the if you observe the whole scenario, that how it is happening in our system. So basically, here, if you are observing, so basically, if you observe this CTPT, so this CTPT, we may have a different type of ratings. So current rating in the primary side may be 100 ampere, maybe 1000 ampere, and the current is reduced here. Basically, the current will be either 1 ampere or 5 ampere. So normally this relay, it will be the circuit, the contact will be normally open. Whenever fault occurs, it will go to the NC, that is normally closed. So the relay contact will move from NO to NC, and the circuit breaker normally it will be closed, that is NC. And when fault occurs, it will go to NO. The circuit breaker, if you observe, when we are having this contact, so one contact it will be movable. So when the trip circuit we are having this trip contact, it will take back this movable contact, and here some sparking will be coming. So why the sparking comes? It is a simple circuit. Whenever we are having a AC circuit and inductors will be there, and we want to open the circuit because there is a fault here in the load set. So whenever you open, then automatic there will be sparking, and because of the sparking, the fire will be coming here. So when you see that the sparking comes under this in between this contact, so at this time, what we need to do, the sparking has to be extinguished. The parking has to be minimized. So to how to minimize that? So whatever the ions are there here, because the voltage has been developed, when the voltage across this inductor is developed, that is L into dI by dt. And why this it is high? Because this time is very less. Because we are talking about the high voltage transmission lines. So within milliseconds, that is, let us tell 20 millisecond or 40 millisecond, one cycle is 20 millisecond, two cycle is 40 millisecond. Within that period, if you want to disconnect the circuit, this total L into di by dt will be high, and the voltage it will coming across the switch. So this switch, whenever you are trying to open the voltage, because of this voltage, high voltage, the air in between this contact, it will be ionized. So sparking comes. So when the sparking occurs, there is a chance that this switch will burn, the circuit breaker will burn. So whenever we are the circuit breaker, we are opening this one, the ionization of this one occurs, and we need to evacuate all these ions which are responsible for the flow of the sparking or the flow of the current, right? So this is done by different type of medium we are having, like air blast. You are having a air blast circuit breaker. So suddenly the air will be flowing in such a way that the ions will be disconnected, moving away from this part. And if I'm talking about oil circuit breaker, then oil is a medium will absorb all the ions. Then SF6 circuit breaker, then what we use a gas that is called SF6 gas. So sulfur hexafluoride, which will be having a high ability to absorb all these ions when the fault will occur. So this is nothing but the total part we are having. The problem here, when you understand the system, is that the problem here in case of our protection is nothing but the sensors we are having. The sensors means what? CTPT, because we need to understand either it is a fault or it is a normal operating condition or it is a abnormal operating condition. Sometimes what happens, many times in our system, since the transmission lines are open to all the system, open to environment, open to different type of disturbances. So we see that many times we are having transient. If the relay detects the transient as a fault, then it will be normally disconnected. So when it is disconnected, we are not getting power. So it means that whenever we are trying to whenever we are trying to put the relays in our system, and if it is detecting the abnormal operating condition, if it is detecting the abnormal operating condition as a fault, so basically what will happen? It will be losing the reliability in our system. Okay. So we need to put the relay so that we'll be detecting all the type of fault, but the condition is it should detect only the fault, not the abnormal conditions like transients and load changes, and some loads are starting, like induction machines are starting or transformer is charged. So this type of condition we should not detect. So the CTPT basically, what is the characteristic of the CTPT? Because the current is really high. All of you know that the CTPT is nothing but a transformer, and we'll be having winding here. And the core is a magnetic medium by which will reduce the current and voltage. Like if we're talking about a CT, that is it uses I1 N1 is equal to I2 N2. The primary number of turns are less and the secondary number of turns are high, so that the current will basically reduce. So current in the secondary side of the CT will be 1 ampere, and the other rated current will be other ratings are nothing but 5 ampere. So when the current increases above certain value, basically whenever fault occurs, suppose here fault will occur, so voltage source is not there, still we are not disconnecting the system. So what will happen? Current will be really high. Why current will be high? Because the I is nothing but equal to E divided by impedance of the circuit. The load is bypassed, so the transmission line impedance are very less. If the transmission line impedance are less, then current will be really high. So the current, whenever the current high current flows, then definitely it will burn everything, right? So for that reason, what you need to do, we need to sense this condition by a relay, and the relay will give a signal to the circuit breaker. Circuit breaker will trip, but the tripping of this one should happen in such a way that the sparking which will occur in the switch, sparking will occur in the switch, it has to be died out. Okay. So for that region, the circuit breaker operates in a closed chamber. It will be having two contact. One contact will be fixed contact, and second contact will be the movable contact. The movable contact is nothing but dragged by this trip coil. Whenever the relay contact is closed, so automatic current flows here. So the trip coil is energized and it will take back the movable contact. So whenever the contact is opened, then sparking will come definitely. So this sparking has to be died out or extinguished. So this is done by different type of medium, right? So this is nothing but our protection of transversal lines we are talking about. The problem is that whenever we are talking about the fault clearing time, fault clearing time means what? Fault clearing time means the total time when we'll disconnect the fault. Like the fault has come and we want to disconnect the fault from our circuit, right? So when you are trying to do that, so basically, basically what is the time we are having, that is called fault clearing time. So this is equal to the relay time. Basically, in case of a high voltage transmission line, we want to operate, we want to dictate the fault within very less time. That is nothing but two cycle. Two cycle means 20 milliseconds is one cycle. Two cycle means 40 milliseconds. So within 40 milliseconds, we have to detect either there is a fault or not. If you detect that there is a fault, then you give signal to the circuit breaker. The circuit breaker will disconnect the faulty section. Okay. Now, in this case, you may say why the battery is there, because whenever the fault occurs, the voltage of this whole system will go down. If the voltage is not there, then how the trip coil will energize and take the circuit breaker contact back, right? So for that reason, this battery should be there. Now, the chances of maloperation of this protection system is such that the CTPT does not inform the relay correctly. Even if the CTPT have given a signal to the relay, relay does not operate correctly. The battery, if you observe here in our relay circuit, if the battery has definitely we know that battery is going to be discharged after some time. If the battery is not correct, then definitely it will be taking a wrong, it will not be having any energy to take the movable contact back in a circuit breaker. The challenge is that for a protection engineer, we are talking about that whenever we are having a this much business, a costly business, and you are putting a substation of 200 crores, but they will be giving us very less amount for the protection system, like CTPT and all switchgear components will be having. So we know that protection system will be getting only 5%. मतलब अगर आपको 100 रुपया मिलता है पूरे सबस्टेशन को डिजाइन करने के लिए, तो 5 ही रुपया पैसे आपको मिलेगा खाली सर्किट ब्रेकर को मतलब ये जो पूरी रिले विले जो है वो उसको बनाने के लिए, ठीक है? But why that much less costly? Because the fault is not occurring all the time, right? Every day the fault will not come. Sometimes someday the fault will come, right? So whenever fault comes, it is definitely we have to detect. अगर fail हो गया तो फिर गया, मतलब हम लोग का पूरा सर्किट जल जाएगा. However, the other condition is that we'll be having a lot of disturbances in our system, like load on, switch off, and many transients will be there in our system because the system is completely open, right? The system is completely open. So for that reason, the challenge is that हमें कम टाइम में करना है, मतलब हमें सर्किट को डिस्कनेक्ट करना है जब फॉल्ट आएगा, और कम टाइम में करना है. कम टाइम मतलब क्या है? बेसिकली मान के चलो कि हाई वोल्टेज ट्रांसमिशन लाइन है तो वो 5 साइकिल के अंदर ट्रिप होना चाहिए. 5 साइकिल में से 2 साइकिल हम लोग रिले को देते हैं. रिले 2 साइकिल के अंदर डिटेक्ट करेगा ये ट्रांजिएंट है या फिर ये फॉल्ट है. और दूसरा क्या है ना, आपका सर्किट ब्रेकर ट्रिप करना चाहिए 3 साइकिल के अंदर. और उसके ऊपर जो आपको पैसा अलोकेटेड है जो कि इस सिस्टम को बनाने के लिए, उसमें बहुत ही कम पैसा है, मतलब 5% 5% ऑफ द टोटल कॉस्ट ऑफ द सबस्टेशन आपको इतना पैसा दिया जाता है, ठीक है? So that is the challenge of a protection engineer who are working in a power system to develop the protection skills. Now all of you know that CTPT, basically the PT will be looking like this, will be having the potential transformers. They are just to measure the voltage. Okay, they one terminal will be coming and it will be going to the primary winding. The secondary winding will be having the so PT will be always connected in parallel. However, the CT is connected in series. So basically CT, if you observe, one wire going, the other wire is outgoing. So it will be also useful for measurement of our current. So this is the minimum oil circuit breaker. So what is a circuit breaker? If you observe, the line is there. So in between that one, if you observe, whenever fault occurs inside this chamber, you are observing these are the chambers. So inside the chamber, the circuit breaker has to open. The contact I told, the movable contact has to be disconnected, or the contact has to be disconnected, right? And this is a basically mechanical relay. Mechanical relay means what? When you observe this mechanical relay, basically So if you observe here that when you are getting this different type of relays, so in this case, you are having the one contact. Basically, this is the point. We'll be having a one time scale here. This is the time grading. So the grading will be nothing but 0 to 1, 0.1 to 1. You see this contact. Okay, you see this contact. This is the contact we are having. So the contact here, this is the contact we are having. So whenever this one will move, if the relay sees a fault, this point will move and it will touch here. This is the point that we are having. So when it will move to this point, it will take some time. So this is the relay operating time. Relay has to operate. It will sense the relay. CTBT will give a signal, then it will see the fault, and it has to operate within fraction of second. If you put this point here, then it will operate in a less time. It will put this point here. This can be movable, right? ये जो आपका pointer है, मतलब ये जो pointer है, हम लोग इसको move कर सकते हैं. तो इसको maximum पे रखेंगे तो ज्यादा time में operate करेगा, इसको कम रखेंगे तो कम time में operate करेगा. ठीक है? तो when this will operate, this point, this thing will be there. It will come down. Okay, the operation of this electromechanical delay is nothing but as you are having the operation of our electromechanical energy meter. So here is a disk. Will be having two coils, that is called current coil and pressure coil. So and when it will be giving the will supply it, then definitely the eddy currents will be flowing over this disk, and because of that the torque will come. Okay, so we can also control the time of operation of this one by selecting the dials. If the dial will be selected as 0.1, then it will be operating at less time. It will select 1, then it will be operating at more time, right? So here this part is nothing but called as time setting multiplier. Okay, so this is a digital relay we are having. So digital relay, basically it is a relay. It will be also having a battery supply. Two supplies should be there. One supply will be from our main supply, that is called power system supply. Other supply, the auxiliary supply, basically it is a DC supply. So that a DC supply, basically it is utilized whenever the power system fault will be there, voltage will be going down, so we cannot sense anything, right? And at that time, if you are having DC, then this whatever the inputs are there, according to that input, this digital relay will take a decision. And the relay in a system, if you observe, basically where we connect all the points, this is nothing but considered as a bus. And when you are talking about this is generator, then transformer, then we'll be having auxiliary buses. And here we are having the different relay. The numbers we are observing here, that is 51, 52, they are number for the relays. Okay, and they will be giving signal to the circuit breaker. The cross sign is nothing but the circuit breaker. A protection relay is a device that detects the abnormalities, that is system faults such as short circuit fault and earth fault occurring in an electrical power system or a power equipment within several tenths of a millisecond, and issues a command to isolate the faulty part from the other normal functioning part. Are you getting? तो अभी तक मैंने आप लोगों को जितना बताया था कि हम लोग को फॉल्ट डिटेक्ट करना है. फॉल्ट कैसे होता है? इंसुलेशन बनने की वजह से फॉल्ट होता है. तो फॉल्ट को डिटेक्ट करके हम लोग को जो फॉल्टी सेक्शन है वो बाकी हेल्दी सेक्शन से अलग कर देना है. ठीक है. Now that may be done by change in current, that is over current relay, that maybe with the time, if you want to operate instantaneous over current relay means immediately it will trip. It will say it's not, we cannot control the time. Time over current relay means we can control the time, like I have shown in the mechanical relay. AC directional over current relay, then distance protection scheme, that is 21 plus, negative sequence over current relay 46, transformer protection schemes, that is 8070, under voltage protection, over voltage protection. These are the different names for our trade names, because if you go to the industry, they will not tell you they will not tell you the overcurrent relay or something. They will be only having 50, 51. This numbers will be written. So from that on, you have to understand it is a overcurrent relay. So Now we need to understand what is the reliability of a system. If the protection system has to be reliable, then it should have two properties. One is dependable and second one is security. Okay, what is dependable? Dependable means what? Like we tell, I always give an example of Mr. Dravid. Whenever he will go, definitely he will score some run. He's a batsman, always he has to score some run. So when we are talking about the Dravid is scoring some run, definitely he's dependable, and we also call him as dependable. So relay, it is there to detect the fault. So if it is detecting the fault, then it is dependable. If it is not detecting the fault, means fault has there, fault has come in our system, but the relay is not detecting the fault. So definitely it is not dependable. Similarly, the second property we are having, that is called security. Okay, the current in our system may be high because of overloading also. So when we are talking about overloading, so what will happen? Definitely overloading increases the current. So because of current increase, the relay will detect it as a fault. In those cases, we'll say the relay is losing the security. मतलब relay जो है secured नहीं है. जैसे आप लोग MCCB या फिर MCB अपने घर में लगाए होंगे, तो MCB जो आप लोग अपने घर में देखते हैं, so what happens if you put a 1 kilowatt iron or 1 kilowatt heater in a 5 ampere plug, what will happen? Suddenly the MCB will go down. You cannot do your work, right? So the work is not secure. So for that reason, whenever we are trying to understand what is the security, अगर हमारे सिस्टम में फॉल्ट नहीं है, तभी भी हमारा रिले बार बार फॉल्ट डिटेक्ट कर रहा है, तो फिर हमारा रिले सिक्योर नहीं है. मतलब abnormal condition जहां पे fault नहीं है, because if you are putting a plug of 1 kilowatt जो कि 15 एम्पियर की लोड करंट खींचेगा, 5 एम्पियर में हम लगा रहे हैं, तो abnormal condition तो है ही, because it is not designed to that 10 ampere, because 10 ampere 15 ampere plugs will be different. अगर आप 5 एम्पियर के प्लग में 15 एम्पियर का प्लग लगा देंगे 10-12 मिनट में या फिर कुछ देर में, वो जल जाएगा, राइट? बिकॉज दैट इज नॉट डिजाइंड फॉर 10 एम्पियर. So for that reason, when you are trying to understand the total, when you are trying to understand the total concept, that what is the relay? Relay is to detect the fault. If it is detecting the fault correctly, then it is okay, it is dependable. But many cases will be having transients. Transients also. Transient means what? जैसे हमने लोड को स्विच ऑन किया, करंट थोड़ा बढ़ गया. ट्रांसफार्मर को स्विच ऑन किया तो करंट थोड़ा इंक्रीज किया इनरश की वजह से. इंडक्शन मशीन को स्टार्ट किया, स्टार्टिंग के टाइम पे इंडक्शन मशीन ज्यादा करंट खींचता है तो करंट बढ़ गया. So if your relay detect the induction machine starting as a fault, then you cannot even start the induction machine. So your system is not secure. Are you getting? So for that reason, relay has to be reliable. Reliable means जब भी कोई भी फॉल्ट हो, वो हमारे सिस्टम में डिटेक्ट करना चाहिए फॉल्ट है. अगर फॉल्ट हम लोग का नॉर्मल ऑपरेटिंग कंडीशन है, नॉर्मल ऑपरेटिंग कंडीशन मींस व्हाट, will not be having any fault, मतलब इंसुलेशन कहीं पे ब्रेक नहीं हुआ है, बट वी आर नॉर्मली ऑपरेटिंग. सो व्हेन यू आर हैविंग ए नॉर्मल ऑपरेशन ऑफ द सिस्टम, ट्रांजिएंट और ऐसा आ गया, तभी भी अगर रिले ट्रिप कर गया तो फिर वो सिक्योरिटी का मामला हो गया, मतलब इट हैज लॉस्ट द सिक्योरिटी. The reliability of the protection can be increased by high technical quality of the all used component like instrument transformer, measuring instrument, batteries, optimal design of the protection, acceptance of the commission, testing, repair and maintenance. Selectivity. Selectivity is required so that only faulty equipment will be switched off. So basically selectivity is provided by using the time grading, fault direction, amplitudes. So we'll be discussing the selectivity one by one. Now you see, particularly in this slide, what you are having, we are having a we are having a protection system. So this protection system, so basically if you observe here in this figure, this is a generator. Generator is having one zone. This is the transformer. The transformer is having one zone, and this is the line, the short transmission line. This is also having a zone. Now, when we are talking about different zones, if the fault occurs here, अगर हम लोग के इस वाले सेक्शन में fault है, तो ये जो breaker है यही clear होना चाहिए. How this breaker will be clearing the fault? It has to clear the fault from both the sides. It means both the breakers has to be operated. So when the fault is there, the circuit breaker from this side and circuit breaker this side has to be operated. So on both the sides, we should be having relay. The relay has to detect the fault and it will give a signal to the circuit breaker. Circuit breaker will operate. At the same time, when the fault occurs, the transformer will also see a fault. But if the fault is there, then this transformer should not detect it as a fault, right? So this is nothing but why we have designed different zones. And any type of relay, the relay is assigned to some zone. मतलब अगर ये एक जोन है ट्रांसमिशन लाइन का, तो इसके लिए एक रिले डिजाइन होगा. तो अगर ये रिले इसके लिए डिजाइन है, whenever the fault occurs, definitely first this relay has to detect. If this relay fails, why the relay will fail? The relay failure may be because of many reasons, like CTPT has not seen the accurate current, the relay contact has not been closed, the battery has gone down, battery जो हम लोगों ने relay सर्किट में लगाया है वो कम मतलब डिस्चार्ज कर गया है, सर्किट ब्रेकर ओपन नहीं किया, सर्किट ब्रेकर को हमने सिग्नल दिया, सर्किट ब्रेकर इज ए मैकेनिकल कॉन्टैक्ट, राइट? वी आर नॉट गोइंग टू चेक इट. हर दिन उसको खोल के या फिर बंद करके उसको चेक नहीं करते हैं कि खुला या बंद हुआ. तो once it is fault, it may be operated, may not be operated. So for that reason, when it is a fault, if this section fault is not cleared by this circuit breaker is not opening, then we have to disconnect the system from this side. मतलब हम लोग को ये पीछे से सर्किट ब्रेकर को ओपन करना पड़ेगा. तो ये वाली जो पूरी सेक्शन है वो हम लोग का अलग हो जाएगा. तो सिलेक्टिविटी का मतलब क्या है? जिस सेक्शन में फॉल्ट है वही वाला रिले और सर्किट ब्रेकर को डिटेक्ट करना है, उसको अलग करना है. अदरवाइज वी हैव टू प्रोवाइड बैकअप. सो फॉर दैट रीजन when you are talking about this whole system, so we need to understand that this is the if this relay is designed for this zone 3, then this is the primary relay for this zone 3. If this primary relay fails to detect the fault, then the backup has to be coming from the zone 2. मतलब अगर zone 1 zone 3 का relay fail कर गया तो फिर zone 2 से हम लोग को ऑपरेट करना चाहिए. So normally what we normally do, we give some time delay for zone 1. suppose we take 0.1 second और zone 2 के लिए हम लोग थोड़ा डिले देते हैं 0.2, that is 0.3 सेकेंड. उतने कम टाइम पे वो ऑपरेट कर जाना चाहिए. ठीक है. So in that one we tell primary relay and backup relay. So we normally provide backup in our system because fault in case in our system should not be लेफ्ट अनडिटेक्टेड. मतलब ये कभी ऐसा नहीं हो सकता है कि ये फॉल्ट हुआ और हम लोगों ने डिटेक्ट नहीं कर पाया. अगर ऐसा हुआ तो फिर हमारा पूरा सिस्टम जो है वो जल जाएगा. ठीक है. इसलिए हम लोग क्या करते हैं, देखो आप यहाँ पे ओवरलैपिंग है. जोन 3 इज दिस वन, जोन 3 इज ओवरलैपिंग बोथ द आगे वाला रिले और प्राइमरी जो पीछे वाला जोन 1 के साथ भी ओवरलैपिंग है. जोन 1 इज आल्सो ओवरलैपिंग दिस सेक्शन. सो the problem of this protection is nothing but we are having different type of zones like closed or open. Closed means differential or unit protection. Open means will be having non-unit like distance protection. So typical protection schemes, as you from this whole lecture what we have discussed, it will be completely overlapping with each other. Like if you observe here how much time we are having to operate the this detect the fault and operate. For transformers it will be having nearly to detect the fault we are having a half a cycle. For parallel line or cable 1 cycle. For bus we are having half cycle. For multi-terminal lines we can go for 1 cycle. For 3-winding transformer half cycle. So basically the time period to detect the fault it is very high, very less. So it is a challenge to detect the fault within a very less time period. As I told, backup protection is also required. So the relay decision should be reliable, should be very fast. Why fast? Because if you allow the fault, then it will damage the whole circuit. Stability should be considered. So what is stability? If you are delaying the delta clearing angle from this circuit, from this instant, so if you operate here, or if you operate go little bit beyond there, then you see